JDD. It's great pleasure for me to see you all here. And I'm Michał Kordas. I work as a software quality engineer in Luxoft. And my presentation is about feedback loops. So let's begin. Feedback, what's that? And actually the theory is pretty simple. We do a thing and we want to know how it went. Was it good or bad? And there are a couple of things that are going here. First one is we want to minimize the latency. So the time, whether we really learn what we did, what we coded, works. And this is about the things that are really done. So not the stuff that is working on our local machines, but ideally the thing that is running smoothly in production. Another thing is that whenever we do a thing and we do not check how it went, we are just building on assumptions. So we are speculating that something will be fine, and this is correct, and what I did is worth any value. So the key idea here is do not do it ever. Always verify, always challenge everything you do. So the idea is to loop as fast as possible. And another thing is that a feedback now is worth much more than the same feedback in the future, like with information. So the information is worth more whenever it's earlier. So loop fast, as early as possible, and no assumptions at all. And that's Agile Manifesto, Agile Manifesto principles. And if you look there, there are many areas where this feedback is there. However, we are on technical conference, and probably you don't want to hear about the soft stuff. So I chose the principle that is a bit less popular, and this is about technical excellence. So instead of talking about business people, getting feedback from them, about optimizing the processes, I chose the principle that tells that you need to be technically excellent to enhance your agility, to make the feedback fast. So I chose several practices that we do in our teams, and I'll just talk about them. Bit of context. My team is pretty small. Right now it's 5 people. We work with about 30 repositories with some bigger or smaller projects, and they are all JVM-based. It's Java, Groovy, Scala. They are built with Maven. Some of them are in Gradle. We use Jenkins to build all of those, and we use GitHub to store our code and do code reviews. And I chose several examples of things that happen and could be great sources of feedback, but usually we just get angry. Something gets broken, we get mad. We get some exceptions, stack traces in logs. We are just lost with those. We're struggling with technology, through project. We are getting some minor comments that are really late. And that's the case when those nasty things that are happening to us, instead of fighting with them and fixing the problems, and that's it, we should always try to make this feedback faster. So those things that are making us angry should be leveraged to, whenever it happens again, at least we know about it faster. So if anything is broken, of course, it should be fixed, but usually it's too late. We are digging in, checking into environments, only to know that some host is down or there is no space on device, and so on. So instead of spending a lot of time each time logging in, checking what went wrong, in my teams, we are using a lot of health check builds. So whenever we notice that something was broken, instead of just fixing it, we are adding a new build on Jenkins that is verifying that this thing is up, and then we are running it periodically, like every 5 minutes, every 10 minutes. And some of those health check builds are pretty simple. We are just pinging some host, whether it responds that it needs to be constantly up. Sometimes we are just opening some ports, maybe performing some HTTP request, checking space on device. But there are also some more complex checks that could really tell whether the entire application is up and running. So the practice is, whenever you notice something is broken, you spend 2 hours to dig in and check what went wrong, instead of just fixing, add new build, automated, and next time you'll know much faster and you'll have precise source of problem before you waste time on digging into things. Another case, exception. So I bet you get such stack trace many times. And the only thing it said is just some runtime exception, maybe null pointer exception, file not found exception, lot of classes, and absolutely nothing to tell you what went wrong. Of course, if you open stack trace analysis in IntelliJ, if you check exact path of the code, you could, after several minutes, learn what really happened. But that's, again, lost time. It's late feedback about the problem. So many static analysis tools tell you to not catch exceptions or throwables, because that's a bad thing. And I would say the opposite. So we should catch them pretty often just to add context. As you see, this stack trace is not meaningful at all. We don't know what operations was performed. We don't know what parameters were passed there. Generally, there should be more information. What was the context of this exception? And this is done by catching and, of course, rethrowing exception. We never want to swallow them because we'll die. So catch, add context, rethrow. If you're struggling with technology, something is not working, something is not integrating, and again, we spend some time learning about it. And there are cases when the Google and Stack Overflow do not help us to solve those problems. So the idea here is that in such case, instead of learning about some investigation and just doing it, try to make the life of the future people that will be struggling with the same thing easier. And how to do it? There is a cool feature on Stack Overflow that you can ask the question and even answer it by yourself. And that may sound ridiculous, why I would ask a question for myself and then immediately answer, but that's the source of the knowledge for others and also for you. Actually, I couple of times I've did like that. And then when I encountered the same problem after several months later, I just Googled the same problem, and my answer was shown at the top because Stack Overflow is pretty nicely, searchable. You get it available for others, but also for you in case you had the same issue again. Then if you're struggling with some internals, something is not fine with your project, you cannot start it, you cannot build it, you cannot run the tests. Again, instead of just doing it and fighting with it and then forgetting about just complaining, always add appropriate steps to your readmes, to your wikis. Never let just your complaints. So there should be always action point. Whenever you have this time wasted, there must be action point. Okay, please document it. Please save the future, you and others, from going into the same issues again. Next time, many people get angry when they receive some minor comments during code review, some space is misaligned, just very minor things that are coming pretty late. So my code is almost ready, and now you're getting me some really minor stuff. And reviewer picks it up and it needs to be fixed, and actually it decreases your productivity after that time. So some people say just do not perform code analysis at all. I don't want to be stopped. But actually the key thing here is that indeed it was too late. So during code review it was definitely too late for such things to be spotted. So the other direction that I would propose, so instead of like forgetting about those, because this also has value, is to try to automate it next time. So whenever you waste time on fixing such issues late, just try to automate them. So automate code reviews, automate checks, and whenever something is not done, you just open new issue, yeah? So I've lost 30 minutes on fixing some issues that could be detected later, but as an action point, I'm just opening new issue, and this should be automated next time. So whenever the next person will take over, they just see automated check, and they'll get feedback much, much earlier to this problem. Next thing I want to talk about is compiler warnings. So it's real. Some person asked on Stack Exchange, how do I convince my teammates to not ignore compiler warnings? And this guy get 10,000 warnings in the project, and he really, was surprised why people are ignoring it. And of course, he gets answers that it shouldn't be done. They are there for the reason, for the case, and there are even cases when people had production issues because of those. So how to get the feedback faster, not in the moment when we get those 10,000 issues and then we need to fix them all, is just to automate those things and enforce no compiler warnings at all in your projects. And then whenever you use Maven, it's just a matter of configuring Maven compiler plugin. There is magic flag, W error, that just treats all warnings as an errors, and then you're getting the feedback about introduced warnings much, much faster. But basically, your project doesn't compile anymore. If you use Gradle, it's pretty similar thing. You just add arguments to the options compiler args. Of course, you can customize it here by xlint minus. You can remove some, compiler warnings that you don't care about. For example, serial. If you don't want serial version UID on all serializable classes, this can be disabled. And of course, you should always, show the warnings at least, because by default, Java compiler doesn't show compiler warning information. So you get only number, and this could be done by xlint all added to your project, and then you'll get detailed info about all of those. So in my environment, we decided that we want to have this information about warnings as soon as possible, and we added everywhere W error, just to prohibit them. Then dependency updates. So would you like to work in a project with such dependencies like Google Collections 0.8, Commons Lang 1, Yoda time even below 1, JUnit 3.7, and so on? Would it be pleasant for you? So how many features would you lose with such outdated dependencies? How many bugs could be there that you just have by not updating? So we also noticed that we want to have this information visible. What should be updated? So what are the possibilities? And to be notified early, just to not let project being very out of date, and then gathering entire team, okay, we need to update dependencies within this project, and this takes weeks. So we are just automating it again. So we are performing reports on all our projects. If it's Maven, we are just invoking versions, display dependency updates, and plugin updates. For Gradle, there is plugin that could be used and just generates for you the report. And such report could be analyzed by developers afterwards, analyze what really should be updated, what brings value, and what not. Then commit messages. So you all know what happens with them when we do not care. So they are getting more and more messy. And then sometimes reviewer catch those problems, but it's too late because this commit message is made, almost all the tests on the branch passed, and now you ask me to edit the commit message. For me, it's again very late feedback because the person needs to amend commit, check in again, run all those tests again, and waste time. So there are two directions they could do. Either you do not care at all and you let people do the mess, and you are happy with it. But if you believe that those commit messages bring value, of course, it's a place to automate it, to have some conventions about commit message, how it should look like, and then just make check that would fail, that would notify developers that this should be improved as soon as possible. So I was looking for some plugin to do it, some job, but actually it was pretty simple to automate it. So if you take this piece of code in Groovy and you just run it, it gives you the commit messages that were done for this branch. As you see, just one liner, and then it's a matter of writing, very simple Groovy script that validates whether it passes your conventions or not. So you put it anywhere. Actually, it can be Gradle task, Maven. Just do analysis, and then you'll get response, whether it is fine or not, and this could be run by anyone immediately, ideally by CI in 5 seconds, giving you the feedback whether it's fine or not. Then build statuses, how to notify that something needs to be fixed. Those health checks I was talking about, or just failed builds on master. So we are using for this just build screens. So our office is surrounded with those build screens. We are having them on a couple of walls, and they are flashing red, of course, if something went wrong. So generally, we should keep them all green, because the quality of information also matters. We don't want it to be always red, because then nobody cares. So keep it green, and whenever something turns red, just action it. And some people go even more crazy, putting some traffic lights there, some sirens, and so on. But we don't find it necessary. We actually just use this Jenkins CI build monitor plugin that looks pretty nice in the recent versions. We run it on the computer with the TV display on the screen, and that's everything that is sufficient for us. But while preparing this presentation, I found these things, siren of shame. So there are people that went much more into this direction to notify loudly and visually the people that really broke the things. So if you check the marketing message on this siren of shame, it tells you, buy it, plug it in, take pleasure from the fear of your teammates' eyes. So those guys are suggesting that we should be scared of breaking the build. We should point this person and say, you broke it. But I would ask the question, why it was possible to break it, first of all? Yeah. So instead of going into this direction of shaming and blaming people, I would rather automate the things in such matter that breaking the build is pretty hard. Actually, it's impossible if the environment is all right. So first thing that we did is we didn't want to merge more pull requests into master branch whenever the master was read. Because whenever we add the changes up to the broken the line, then the things are getting only worse, because it's harder to check what went wrong, and people start to not care. So the first thing that we did is we created plugin to browser, because GitHub doesn't offer this functionality yet. So whenever some Jenkins jobs are read, it's blocking the button. So instead of blaming the people, you merge the pull request to the read master and pointing them out, and feeling them ashamed, we just technically block the possibility to merge pull requests whenever they shouldn't be. And if it's fine, if master is green, we are just turning the icon green, and you can merge those pull requests without any issues if the master is green. Then, of course, another thing that we are doing is we need to run all the tests on the branches. So if you do not run them all, then of course it's a possibility that we merge something, and then on master it will turn red. So we are using many parallel builds that are executed on each branch. that are giving us the feedback. Is it ready to be integrated? Will the master be green after your changes are integrated or not? And we're encountering the problems when the things were good on the branch, so the branch itself was good, but after merging it, even without getting any merge conflicts, the things were not integrating fine. So what we notice is really nice thing to have is that we should always merge those changes before running the builds. So do not run them just on branch, because the branch can be really outdated. Merge master and then run your checks. And it gives you, the mirror feedback, not only about if the branch is correct, but also if the result of merging is correct. And then we are using heavily this GitHub status API. That is really simple thing. So whenever you don't have a plug in your current CI, that's also not an issue at all, because it's a matter of just executing one post with the address of repository and commit, and sending really simple JSON on what you are updating. So please use this GitHub status API. It's really simple, just to give you full feedback whether this change is fine or not. There was even a feature recently introduced on GitHub that could give you 100% confidence whether the things that you developed will be working fine after integrating. It's a check that require your branch to be fully up to date with master before merging. Because if it's not up to date, it can be misleading. It can be fine itself, but after merge, the result can be different. So if you require this branch to be up to date, then you cannot just merge it, and you need to update it and run the tests again. So you see there is even button that you can do it. The only drawback is that you need to run, of course, all your tests again. So this can be issue sometimes, but whenever you keep them parallelized and fast, and your project are small enough, that's really convenient way of being always safe and not letting the master to fail at all. Another thing that we noticed is visually nice, that is giving us information on the repositories, are just shields or badges that we apply in the readmes. So whenever you open some project, and I gave examples of open source Checkstyle and Mockito, you get entire dashboard of information. What is the status of the build, whether it's passing or failing. You get information about the latest version that is released pretty quickly. Then you get information about some quality checks, like in Checkstyle, some technical debt, whether the dependencies are up to date. You immediately have the buttons to join the chats to reach developers. So the service that is providing those is Shields.io. You can use it by yourself. You just set up the link that is telling you the relevant information, and you are done. And those repos, whenever you open them, are giving much more information to you at a glance. Then another thing that we notice is pretty convenient to have is some button to release the software. So you open a repository on GitHub and you want to really quickly release it, to ship it, instead of looking on wiki or going in very deeply into README. So the direction that we are going is to have in each repository such button. So whenever you open it, it's on the top, you press it, you ship it, you open probably Jenkins with some configuration, you provide the version, and you specify where it should be deployed and so on. But having this button also saves us a lot of time how to find this data. Then unit tests. When we are talking about fast feedback, they must be mentioned, because it's the core to get the fast feedback, whether our changes are good, whether they are working or not. And there is a set of principles that is called FIRST, that probably some of you know already, but I would like to remind you of those, as they are really important and they should be understood literally. So what are good unit tests? So those are the tests that are running hundreds per second. They should be really fast. They should not use any external resources. and they should be repeatable, always giving the same result even if run millions of times on your local machine. They should be isolated, so there should be no interference between those, just to give us this repeatability. They should give really clear information whether the status is fine or not, so there should be strong assertions in those, and written as soon as possible, either just after or before, doesn't matter, but they should be provided. So that whenever we run this MVN test, Gradle test, or we just press Shift F10 in our IDEA, we want to get immediate feedback about our changes. And those test stages, they should not last for hours or minutes. They should rather tell you in seconds whether the changes that you've coded are fine, and all the other checks, the heavy checks that you perform afterwards, they should be separated. So they go to separate phases to have at least this fast feedback quicker. Do not wait hours to learn whether the things that we did break some really basic stuff. So how to guarantee this repeatability and isolation is by running them in parallel. We just want to execute the tests in parallel, so whenever they have any dependencies, they will be visible because we'll shuffle them in random order. So in Maven, you can just set up run order random. You can say run all of them in parallel. So you're taking just totally random order between different classes and within classes, and just by specifying, that I want to have one thread running test per core. It also gives you the performance of the build. Usually it is then faster, but first of all, this guarantees that the things are isolated. With Gradle, it's also pretty simple. You just specify max parallel forks in your Gradle build. So we find it really useful in our environments to give us faster feedback about what is going on, whether they are really independent. So the thing I showed you on the previous slide was only about tests. But there is also possibility to parallelize the build to make it faster. So the idea here is to split them into modules, and that's the direction that we are going right now. So instead of having one big module monolithic that is taking half an hour or hour to verify, we are making small modules. And if you have those small modules, then we can parallelize execution of them. So if you use Maven, we just run it with -t and providing the number of threads to use. And if it's Gradle, you just say parallel and parallel threads, and you put the number. Usually, if it works fine with 4, 8, something like that, about one thread per your core. It could be 2. Depends. You need to play with it. What is the fastest and what works for you the best. Generally, it speeds up a lot if they are independent. So if modules are independent, it's nice. The only drawback is that the console output gets messy. So sometimes you may want to have two suites. One that is serial, that is giving you cleaner output, that runs longer, but it's more deterministic, and another fast that is parallelized, and you get the feedback immediately. Then we've noticed that it's really easy to speed up the Gradle builds. So there are some quick wins to make those faster. Like we can enable just incremental compilation just by putting one flag. It's not enabled by default. So if you just put it in your build Gradle file, you'll get benefit of compiling only the things that are changed. Then if you run old Gradle, it's really worth updating. First of all, because they use the daemon by default from Gradle 3.0, and it speeds up the build significantly, even by a couple of seconds to start and load all classes. But also, if you look at release notes of each Gradle version, every time they mention improved performance. So they're doing a great job just to make the build faster, and indeed the build times for us are spinning up each time. So how to update Gradle? If you use wrappers, and I really recommend you the wrappers because then you can maintain the Gradle on the project independently. It's just by executing this command. You just generate new wrapper with the latest Gradle, and you are done. You are using the latest Gradle. You don't need to install anything on the system like with Maven. Then there is also a quick win with using JCenter. So JCenter is kind of extension of Maven Central IDEA. It contains all the artifacts that are on Maven. It's supposed to be at least not slower, usually faster, because they have more servers all around the world. And they have even more dependency than Maven Central. So just by simply replacing those two, you can get another speed up. Then Gradle in the recent versions offers a lot of things to analyze your builds, and it could be done locally by executing Gradle profile. Then you get a nice report of what is going on inside, or online Gradle build scan. So you run your build with -d scan flag, and then entire report is uploaded to Gradle to analysis, saying you what took the biggest amount of time, what could be optimized, just to really see where you are losing your seconds. Static analysis. So we are using those tools, check style, PMD, find bugs, code narc. And until some point, we had configuration per repository. So each repository had its own configuration. And actually, we find this situation really messy because some of those repos had just copy-pasted some old configs that were not updated. Some of them were just omitted, or the tools were configured improperly, because that's the case. Those tools are not that easy to be configured. It's not enough just to put some snippet of code copied from Stack Overflow and you're fine, you're having those tools. They require some time that is put to understand how they work, how they should be configured, and to make sure that all relevant rules are really enabled. So we find that having this common set of rules that are tuned for the project or for the company is helping us a lot, because we are, predictably we know what standards they should meet and what to expect from those tools. So we agree that we'll use common configs, and there are 4 ways that I know how to do those. So one is just put them online, put those rule sets online, so they could be downloaded by each project and shared. This has drawback because, again, each project needs to configure those tools manually, and it's not as easy as putting the link to rules. There are many also other settings that needs to be specified for those to be run. So there is still a possibility that you misconfigure in some, I don't know, new project or some old that is not maintained. Another way that we are using right now is Gradle plugin. So the Gradle plugin takes care of everything, sets up them correctly, and you are good to go. Similar approach would be by writing Maven plugin, your own, and actually do not be scared of it. Do not be scared of writing plugins. It's really easy. In case of Gradle, it's a matter of implementing, extending one class. So you are just implementing one method in that class, and you are good to go to write plugin. You have project object, and actually there is absolutely no magic around it. Another way that some projects are using is specify those configs in parent POM. So if you're using Maven, you have this inheritance model, and then you could specify that your parent has everything configured, and then you just inherit from it. But I would say it's really tricky, because it works fine until you use those defaults. But whenever you want to customize, I always struggle with this POM inheritance and the overriding rules. So it's not that easy to just override one setting from the parent in those XMLs. You still have some required sections. You cannot, just specify minimal amount of information that you want to override. It's getting really tricky, and you can mess with it. So plugins, like inheritance and composition, I would say the plugins are composition and they work better for us at least. Then, as I told you, we have this internal quality plugin that takes all of those tools and configures them properly. And by default, we don't have 0 configuration. So to enable all of those tools, we just need to apply those plugins and we are good to go. We don't need to spend time tuning them. And it actually helps us a lot to spin out new products. We just apply this plugin and it cares about all the company or project practices that should be taken care about. Then we also, add some enhancements. As we integrate many tools in one internal tool, we, instead of having necessity to run all of those tools separately, we just invoke, in this case, it's Gradle quality, and all of those agreed checks are run. Also, we unify the output from those tools, so we're getting the clickable links on the console. So whenever there is any violation coming from those tools, you just go to console and you have clickable link in the IntelliJ that brings you exactly to the place the code to be fixed, and that speeds up the feedback about those violations significantly. So we don't lose time going into some reports of those tools separately. We have unified report in one place. Another trap that you may fall with those tools is to do configuration based on whitelists. So you choose some set of rules from those tools and you put them into XMLs and you think you are fine. And it works fine, but those things are really getting outdated pretty soon, because in those tools, new rules are added, they are changing names and so on. So maintaining whitelist of rules that you want to apply will let you either to have a lot of work with them, or you will be outdated and having really poor analysis. So what we find is working the best for us is just providing blacklists. So if there are rules that are not providing value for us, it's not worth to enable them. We just specify those, and all the others are enabled by default. And then when the update of this tool comes, we are getting all the new rules by free. If they are not fine with us, we exclude them. But usually we don't have any work associated with enabling new stuff, just disabling. Then, if this feedback from Gradle is a bit too late for us, then we can apply plugins like Checkstyle IDEA, Findbugs IDEA that would highlight the code immediately in the IDE whenever the violation is made. So this Checkstyle IDEA works in half a second. So instead of waiting for CI to spin up all the builds and just to learn that some space is misaligned or thing like that, we can get this feedback just as we type with this plugin. Also, we can scan with Checkstyle or Findbugs just before doing commit. So with those ticks enabled, then you actually do not have possibility to commit anything that is breaking those violations. So I really believe that people get angry on those tools just because the feedback is too late. Whenever the feedback is immediate, you're getting it as it types, it is no pain at all. And you are not going to get any style comments or minor comments during code review or the things that could be automated. Just fix it on the fly and forget. Do not, spend time on holy wars and saying, oh, it's waste of time and so on. Another nice tool is SonarLint that you just install, and even without SonarQube instance, you will get immediate feedback about the bugs in your code. Basically, this focus there is not only about style, but mostly about the bugs. So the more tools that are telling you that you made a really nasty bug, like some possible null pointer and so on, the better. So we want to learn about those immediately. Then we have this internal quality plugin, and we notice that okay, it's fine, but actually it was stopping execution on the first violation, the first tool that gave violations. So we wanted to have this full quality report. So if someone forgot to perform those checks locally, instead of learning in Jenkins that we made some PMD violations, and then after pushing changes there is Findbugs violation, and then after pushing next changes you get let's say PMD violation, but in another module, and having this late feedback about all possible violations was waste of time. So actually notice that it's enough to provide the flag continue to the Gradle builds, or in Maven it's fail at end. And what it does, it gathers all the violations or the failed tests in your project and then presents it in one report for you. Look, this is your code. I've performed all the possible checks, and here is the feedback for you. Full feedback about the entire project. It's not failing fast, so probably you want to have another build that is failing fast and telling you, hey, you will have problem with this build. And then after some time, the full report comes to you whenever, and you can just fix it all at once, not one by one. Another thing that we notice is that there is significant amount of things that needs to be done in each project to apply the things that I was talking about, just to make the Gradle more usable. So we noticed that instead of copying and pasting those things around the project, and then forgetting about some things in some project, doing things in different ways between those, we want to have them unified. So we gathered the list of things that I have specified here, and we put it all into plugin. So we have our internal plugin that is supposed to be used with each project, with each repository, and whenever we notice that something is worth using and should be used because it's improving speed or giving better feedback for us, for example, about failed tests, if we can automate using latest Gradle, having some nice plugins integrated, some more information about, current Gradle version or JVM, we put it all into this plugin, and then we get all of those things that are improving things by free in all projects, even small ones. And this is really enhancing our agility to set up new project again, because whenever we set up new project, we know that we just apply this quality plugin and base plugin, and we have all the good stuff already there. We don't need to spend any time just thinking how I should set up the project so that it meets all the feedback standards and so on. So in Gradle, it's really simple. In Maven, I believe it's also just a matter of writing some piece of plugin in a repository and applying it all around. All right. Performing all the checks on the branches and on mastery, it's fine, but sometimes it still happens that, okay, it works on CI, but it doesn't work for me locally because, I don't know, I'm using some custom local, or I don't have cache of repository and so on. So people were getting into such trouble locally, and we're getting feedback about those things late. So let's say the project is building fine on all developers' machines. It's building fine on CIs, but then new joiner comes, and they learn the project doesn't compile. And how it is possible? Okay, everyone has cached some dependencies, had some custom settings in, setting XML, Gradle properties, whatever, and it worked for everyone, but not for the new joiner. So again, instead of teaching this new joiner, okay, that's the things that we should do, and resolving problems, then we just have some build matrix that is running on master, and those are not tests to, challenge the product, because this must be done within main pipeline. These are the things that guarantee that project will always be buildable in different environments. So use different Gradle, Maven versions, Java versions, use various parameters that developers may use, and so on, just to make sure that whoever comes to your project, it's safe, it will always be building. And whenever someone introduces some problem in the code that makes this project not buildable for others, we get the feedback within a couple of hours. Of course, it would be overkill to run those on branches, like for every build, but whenever you notice something is being broken often, just move it to the branch. Yeah, just to have even faster feedback. But normally it's enough to run it, I don't know, every night and so on. Then mutation testing. You don't know what's that. When I first time heard about mutation, I thought, okay, that's something horrible. What is going to do with my tests and so on? And indeed, the idea here is to have mutants. But as you see, I've explained the entire theory behind mutation testing just in the first bullet point there. So we made some mutations to the production code, some random changes, and you run the tests. And the idea here is that at least one test should fail, saying that you had mutated code. So this code doesn't behave how it should. If all tests are passing still, for example, you change some assignment or you change some equality, that means that you didn't have tests for it. So the percentage of the mutants killed, so the more mutants we kill, ideally we should kill all of those, the better quality of the code. However, the thing here is that usually it goes really slow, because you need to run all of the tests for each mutant. However, we found the thing that could speed the thing up. It's ptest plugin, SCA mutation coverage. So instead of running, all tests on all code and killing those mutants, we are just running those tests connected with the changes. So by applying this plugin, you can run those tests in a few minutes to give you faster feedback about those mutants. So whenever you introduced some changes, you add a new piece of code that doesn't have enough tests, you get this feedback that, okay, some mutants were not killed. However, of course, this is rather informational thing. So we don't want always to kill all mutants, because the amount of unit tests should always be reasonable, and sometimes you are just making tests that are unnecessary, that doesn't provide any value. So in latest GitHub, there is idea of required checks. So there are some checks that must be passing, like, of course, project needs to compile, passing all quality standards and tests, but there could be checks that are not really required, that are just for your information. And mutation coverage fixed nicely here. So we have just some informational thing. Hey, I found some mutants that were not killed. Please fix them if you find it reasonable. Then there is another nice tool. It's called Nondex. It's a tool about detecting wrong assumptions about Java APIs. So there are several Java APIs that do not have guaranteed contract. Let's say hashmap, key set, or hashmap just get doesn't provide any guarantee about the order that you will get in elements, and some of our tests are basing on it. So first time I've learned about such stuff is when I was upgrading Java, yeah? So the test was working on Java 7, but it's not working on Java 8. Why? Because they changed implementation of hashmap, and the test was basing on some particular order of iteration. And this tool just modifies underlying Java classes, permutates the results from all of those APIs that do not have any guarantees, and runs the test. And it's similar to mutation testing. You want the tests to pass always, doesn't matter what's the order returned by those methods. Another thing that we find useful is to play with committing IDEA files, just to enable inspections that are disabled by default and they provide a lot of value, or just by sharing the code style within the repository, so that you don't need to download any configs, you don't need to set up manually, you check out the repository and you have all of those files committed. Another thing that we really want to go into is to have ability to set up new Jenkins slave just whenever we need them within a couple of minutes. So we have jobs to set up new hosts whenever we have amount of checks on our Jenkins that make our host overloaded. We just set up new node, and this should be really easy. So there is job to set up. There are some plugins, and it should ideally takes you just a couple of minutes to set up new host or disable for your purposes. It shouldn't be a work for days to add some hosts. We want to have those statuses on pull requests quickly. The fast feedback there should take place. So whenever you have too little hosts on Jenkins, let's say, those builds will get queued, and you will not get any feedback whether the tests have started or not. So instead of wondering what is going on, whether my hosts are overloaded, we have separate executor just for triggers. So whenever the pull request is opened, there is always free executor with a lot of resources and space just to learn about this new pull request and notify the GitHub about what is going on. And it can say, OK, I've just submitted into build queue and it's waiting, but at least I get this feedback immediately. I don't need to wait and wonder what is going on. And then finally, pipelines. So the pipeline is a concept when you have all the things that are between your code and production automated, and you just build artifacts only once, and going through all of those checks, going through entire pipelines, says you whether the commit, the particular tag in Git is deployable to production. It's fine to be released. So it's how it works for us. So the first step is just to trigger, that there is trigger on master, there is new commit on master. It's here we have the Git hash displayed, the version of the software, and then we execute all the tests. So Gradle build says and builds artifact, executes all the tests, and that's just the first stage. So of course, usually every larger distributed application is not ready to production just after building it and executing all the fast tests. So then there is another stage of verification. So we want to take the entire application that is built already and run into many challenges. And those are system tests on some real environments, and that are taking those jars, spinning up application on some grid, and challenging it in many various ways. So again, the idea here is to parallelize it. So build application once, have one jar quickly, like 5-10 minutes, but then run on parallel many lengthy checks. So you will need many hosts for it, of course, but then you can run through those heavy system tests quickly. And whenever those changes challenge, OK, it's fine, it passes the test on real environments, then you have this promotion stage. You can promote artifacts to some repository when it's supposed to be ready to release to all environments, including production. But also we had some additional verification. The verification that was not fitting, the fast tests, like performance tests, that were taking more time, significant amount of time. So we added like additional verification that is run every night afterwards, just to additionally verify whether this commit is ready to be released. However, this would be rather intermediate step. So whenever you have tests that are too slow, you can put them separately as additional step and run them periodically whenever you need it. But the idea here is to use your technical excellence, use all the skills to move those additional verification, back to the standard pipeline. And that's the thing that we're working on. We are speeding up our performance tests. So optimizing performance tests is also a job to be done. Code reviews. Just do not let the author of the code to wait too much. You should address your comments, and in latest GitHub you can even address comments to the particular people or the teams. You should assign people so that who is reviewing it. Then we have dashboard. Actually, every GitHub instance has dashboard of open pull requests. So you could just open GitHub pools, and you'll see all the pull requests that are open in your project. And actually, there is search bar that you could put your query in, and you can analyze your projects and display all the pull requests that are waiting for feedback, just to not let them lost there. So we also have contributing files, so which repository has contributing MD with some short information how to contribute, so that the feedback for the people from external teams is faster. So we know what are the rules there, and it could be just linked to wiki page describing it. Latest GitHub version also works on the quality of feedback, not only on the speed of feedback, but also they notice that when we do reviews, it's better to receive one feedback that is straight to the point. So they introduced concept of pending comments. So you do review, you can edit them, add them into different places instead of putting those comments one by one to the author and having feedback that is noisy. Just do one review, submit it, and say explicitly what is your result. It's just comment, or maybe you request some changes, or it's approved. Then retros to finish with. So those are standard things, so Starfish, Met-Set-Glad, and so on. But we think that we should just have fun. Yeah, so we are not stopping into those simple, ways to make retros. We are using these speed carabes, speedbow, and so on, just to have fun on those to gather more and more feedback. And if you're scared and you don't really know how to run your retros by your own, you can use dialog sheets that are leading you through all the steps for good retro, naturally. You just read and follow retrospective. And to finish with, that's what Elon says about the feedback and having this feedback loop. He just says that you always should learn what you are doing and make things better and better all the time. So just continuously improve, deliver more value with it. By doing it, you reduce a lot of risk, learn, and as you see, feedback has really many types, many sources. Just try to leverage all of them as much as possible, even in those tiny technical things. So just remember, there is no failure at all. There is only feedback. Thank you very much.
Thank you.